Previously, in module number 1, module number 2, number 3, number 4, or even the beginning of module number 5, we learned that we have a force with a value, for example, 10 kilonewton, or a force with a value 20 pound. This force is called concentrated force. Only one arrow located at one specific point. And this is called concentrated force. Sometimes your force is not concentrated at one point, it's distributed. And this load looks like this shape. We have a body box like this one. This box is rested on the table. So this box is not just rested on a point, it rested on an area. So the load which is coming from this box on the table is distributed, not concentrated. That makes sense? This is the idea of distributed load. Another example, if you look to a wall, fence around the yard of your house, this fence is not concentrated at one point. This fence is distributed over this line. If you are talking about the ground surface. So we don't have one point load, one concentrated load. No, we have distributed load. So sometimes we have this case in our problems or in our structures, distributed load. The distributed load has different shapes. Sometimes your distributed load looks like uniform. The value of the distributed load is constant over the length. Sometimes it's non-uniform. Looks like trapezoid, looks like triangle, right angle, triangle, looks like this triangle. So we have different shapes of the distributed load. The question is how we can work with this distributed load. We need to convert this distributed load to one concentrated equivalent load. I need to combine this distributed load to one concentrated load to work with. If you have uniform distributed load, looks like a rectangle. This shape is a rectangle. So I can convert it to equivalent. Looks like this. At the midpoint. Why the midpoint? Because the midpoint is the centroid of your rectangle. This equivalent load will equal the area of this rectangle, Q times L. So I can say the value of the equivalent force equal area of the distributed load. This is a rule, rule number 1. Location of this equivalent force will be at the centroid of the distributed load. These two rules are very important. Please keep them in your mind all the time. For any distributed load, whatever the shape, uniform or non-uniform, we need to convert it to one concentrated load, which is equivalent. So if you would like to figure out the value of this concentrated equivalent load, you have to get the area of this distributed load. I mean, if your distributed load is uniform, that means the shape of the distributed load is rectangle. The area of this rectangle equal this height times this length. If your distributed load looks like right angle triangle, the value of the equivalent load will be this area, which is 1/2 times base times this height. That makes sense? So the value will be the area of the distributed load. The location, keep in your mind, the centroid of this rectangle at the midpoint. So the equivalent force will be here. The centroid of this right angle triangle is here at 1/3 from this side and 2/3 from the other side. 1/3 L, 2/3 L, where L is the total length. This is the location of the equivalent. How much? This height is called W. This height is called W. So the area of this rectangle will be W times L. It's the area of rectangle, length times height. The area of this right angle triangle, 1/2 times length times W. That makes sense? If your shape looks like this triangle, symmetric, this triangle is symmetric. So this height is called W, and this total length is L. If you would like to figure out the equivalent, first of all, the centroid of this triangle at the midpoint. So the location of this equivalent is here. How much? The area of this triangle is 1/2 times base times height. If you have trapezoid, looks like this. How can I work with this one? Unfortunately, yes, I can figure out the area of trapezoid, but where is the centroid, the trapezoid? I cannot figure it out. Nobody knows where is the centroid of the trapezoid. So I can divide this trapezoid to two shapes. The first shape is this rectangle. And the centroid of this rectangle at the midpoint, and I can get this equivalent. So this equivalent only for the rectangle part. The remaining part will be this triangle. The centroid of this triangle at the 1/3 and the 2/3. Here is the equivalent. And I can figure out the area of this right angle triangle. That makes sense? So keep in your mind, we don't have any more cases, only 3 cases. Case number 1, if you have uniform distributed load, rectangle. Case number 2, if you have right angle triangle. Keep in your mind, the centroid of this right angle triangle at 1/3 from this side and the 2/3 from the other side. The third case, we have triangle, which is symmetric. So the equivalent will be at the midpoint because the centroid is here at the midpoint. If you have trapezoid looks like this, I can figure out the area of trapezoid, but where is the centroid? So this is the reason why I will divide it to 2 parts. The first part is this rectangle. So I can convert it to equivalent like this at the midpoint, and the value equal the area of this rectangle. And the second part, which is the remaining part, is this right angle triangle. Keep in your mind, I need to figure out what is the value here. Then the equivalent will be at the centroid, which is located here at 1/3 and 2/3. Anybody so far has any question? I will do more examples right now, but so far, do you have any question? Let's start with this one. We are given a beam fixed at A. So A is fixed support. So if you would like to remember what was or what were the reactions at your fixed, remember, we have 3 reactions: vertical force, horizontal force, and moment. The horizontal force will be called XA, the vertical force will be called YA, and your moment, I will call it MA. This is the first step, because A is a fixed. Second step, we are given uniform distributed load looks like trapezoid. So I cannot figure out where is the centroid of this trapezoid to locate the equivalent force. So I will divide this trapezoid to 2 parts. The first part is this rectangle. This rectangle will have a centroid at this point, at the midpoint, which is 4.5 and 4.5. And this is the location of your equivalent force. What is the value of this equivalent force? The area of this rectangle, which is 50 times 9. 50 is this height, is given like 50. The total length of this rectangle is 9. So 9 times 50 equal 450 pound. So I have equivalent force here equal 450 pounds. The second part, or the remaining part of this trapezoid, is this right angle triangle. Hey guys, anybody in this room can tell me what will be the height of this right angle triangle? Is it 100 or something else? Any help? What will be the height of this right angle triangle? This part from here to here. It will be what? Any help? Thank you. Yes, it will be 50. This part is 50. Keep in your mind, this 100 from the bottom is 100, but I use the 50 for this rectangle, so the remaining will be 50. So the centroid of this right angle triangle will be here, 1/3 to 1/3. This is the location, and the area will be 1/2 time base time height. The base is 9, the height is 50. If you multiply time 1/2, you can get the area. So 1/2 times 9 times 50, I got 225. If you would like to make it more clear, I can redraw the beam like this. Here is the beam. Here is your fixed. So I will have 3 reactions. One vertical, one horizontal, and one moment. MA, XA, YA. I will have equivalent force here equal 450 at midpoint. So this distance will be 4.5 feet, and this distance will be 4.5 feet. And also I will have equivalent force here equal to 125 pounds at 1/3 from this side and 2/3 from the other side. 1/3 of the 9 will be 3 feet. 2/3 of the 9 will be 6 feet. Does that make sense? So I converted the given distributed load to equivalent concentrated forces. Then I can start to apply the 3 equilibrium equations. If you remember, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Please give me a hand. What forces do you have in this beam in x direction? If you look, you will see that we have only positive XA. Nothing else. So this reaction will be 0. If you apply summation f of y equals 0, I have positive YA, I have negative 225, I have negative 450. Looks like we have question. Will the load always be given as pound per foot? Yes. Force per unit length. You force unit per unit length. No. Everything will be given, all the loads will be given force per unit length. Pound per foot, Newton per meter, kilonewton per meter, kb per foot. So force per unit length. One more time, summation f of y. In y direction, we have positive YA, we have negative 225, negative 450. Nothing else in y direction equals 0. From this equation, I can find the value of YA. Looks good. The value of YA will be 675 pounds. So far, so good. The third equilibrium equation, because keep in your mind, yes, I found YA, I found XA, but still looking for MA because MA is a reaction. At the fixed, we have 3 reactions. So keep it in your mind. So for the fixed, I will take moment at any point equal 0. I give you a recommendation last meeting that I will take moment at the point of the highest number of reactions. So I will take moment at A. I will assume my clockwise rotation is my positive. Then I will start. I have MA time what? I have XA time what? I have YA time what? I have 225 time what? I have 450 time what? Equals 0. Just a reminder. We have something called the moment. This moment equal force time distance. And your force and your distance must be perpendicular. If your force is vertical, your distance must be horizontal. If your force is horizontal, your distance must be vertical. Sometimes we don't have distance, it's 0, sometimes. So I have to list all of them. Everything in the problem should be included in this equation. Let's start. I will ask a question and please answer me. I am sitting at A. So I am here at A. What is the distance between XA and A? What is the distance? I need answer. What is the distance between XA and A? What do you think? 0. Looks good. What is the distance between YA and A? One more question. What is the distance between YA and A? 0. Thank you. The third question, and be careful. What is the distance between MA, because we have 3 reactions at point A. What is the distance between MA and A? What should I write here? What is the distance between MA and the point A? Be careful, it's a trap. You said the distance between XA and A is 0. Looks good. That's right, because XA is located at A. The distance between YA and A is 0, because YA is located at A. We have MA also located at A. So what is the distance between MA and A? Anybody has any answer? Zero? No. Keep in your mind, if you would like to create a moment, you should have force and the distance to create this moment. Since MA is a moment, so we don't need distance here. I will take this MA as it is. Does not need distance. The only term that need distance is a force. XA is a force, need distance. YA is a force, need distance. 225 is a force, will need distance. 450 is a force, will need distance to create moment. But MA is a moment. Reaction as a moment does not need distance. If you write 0, it will be wrong. That makes sense? If you are given a moment as a reaction like this one is called MA. You need to take this value as it is without distance, because it's a moment. I cannot multiply moment by distance. No need for this. If you have force, you need distance to create a moment. But if you have a moment, take it as it is. Keep going. What is the distance between 225 and the point A? What is the distance? What is the distance? 1/3, 3 feet. What is the distance between 450 and the point A? Half distance, 4.5 feet. Do you agree? If you have any comment, just let me know. This term, I don't care about the sign of this term because it will be cancelled. This term, I don't care. My concern is you assume the clockwise rotation is positive. Unfortunately, MA is counterclockwise, so it will be negative. 450 times 4.5 will be clockwise positive. 225 times 3 will rotate clockwise, it will be positive. Any rotation clockwise about point A will be positive. Any rotation counterclockwise will be negative. The only unknown in this equation will be MA. So I can figure out the value of MA, which is the third reaction in this problem. MA will be 2,700 pound foot. This value is positive. This value is positive. That means you assumed the correct direction. This is a trick. Be careful. If you have a moment as a reaction, this moment does not need distance. This moment does not need distance. Don't multiply this moment by a distance. Let me do another example. This one. We are given a triangle, but this triangle is not symmetric. Be careful, there is a big difference between if you are given a triangle looks like this, which is symmetric, and another triangle which looks like this. There is big difference because this triangle, I can figure out the centroid, which is at the midpoint. So I can locate the equivalent. But this triangle, I cannot figure out where is the centroid. So what should I do? Nothing. Just divide it to two right triangles. This one alone with a centroid here at 1/3 and 2/3. And this one alone with a centroid here at 1/3 and 2/3. So I converted my triangle to two equivalent, one here and one here. Does that make sense? So this is the case here because this triangle is not symmetry. Okay, first of all, A is a roller. If you have roller at A, that means I will have only one reaction, YA. B is hinge, so I will have two reactions, YB and XB. Next step, I will convert this distributed load to equivalent. As I mentioned, because the triangle is not symmetry, I will divide it to two parts. This part has a centroid at this location, 1/3, 2/3. 1/3 means 1 meter, and this distance will be 2 meters. 1/3 of 3 and 2/3 of 3. So the value here will be how much? 1/2 times 3 times 6. 1/2 times base times height. It will be 9 kilonewton. The second part, this one, let me choose a different color. This one, with a centroid located here, 1/3 of the 6 will be 2. 2/3 of the 6 will be 4. The equivalent will be located here. How much? The area, 1/2 times base 6 times height 6 equal 18. If you would like to draw another copy with clear sketch, so I will have reaction here YA, I will have two reactions here YB and XB. I will have equivalent here with a value equal 9 kilonewton, and this distance is 1 and this distance is 2. I will have another equivalent here equal 18 kilonewton with a distance 2 meter and another distance here 4 meter. Then I will start to apply my equilibrium equations. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. What forces do you have in x direction? Nothing, only positive, negative. xb equals 0, so the reaction xb will be 0. We don't have any forces in x direction, which is very easy. Summation f of y, I have positive ya, I have negative 9, I have negative 18, I have positive yb. Nothing else. Nothing else. So I can simplify it. So ya plus yb equal 27. The third equation will be summation moment at any point equals 0. I do recommend it to take moment at B. The highest number of reactions. B has 2 reactions. And I do recommend to take the counter clockwise as my positive. It's up to you. So any opposite direction will be negative. Then XB time distance, YB time distance, equivalent 18 time distance, YA time distance, equivalent 9 time distance, equals 0. I have to include everything in this equation. If you have a force, we need distance. If you have a moment, does not need distance. Hey, keep in your mind, we are sitting at B. We are sitting at B. So what is the distance between XB and B? 0. What is the distance between YB and B? 0. What is the distance between 18 kilonewton and B? 4 meters. What is the distance between YA and B? 6 meters. What is the distance between 9 kilonewton and B? It will be 7 meters. This one plus this 6. I don't care about this sign, positive or negative. I don't care about this one, positive or negative. I think 18 times 4 will rotate counterclockwise. I think YA times 6 will rotate clockwise. It will be negative. I think 9 times 7 will rotate counterclockwise. It will be positive. The only unknown in this equation is your YA. So I can figure it out. It will be 22.5 kilonewton. Let me check it again. Yes, 22.5. If you go back here and put YA 22.5, I can find the value of YB. It will be 4.5. Is it correct? Yes. So by the end of the problem, I found the 3 reactions of your supports: XB, YB, YA. Any question? The remaining questions are very easy. The same meaning for this shape. I have roller at A, so I have 1 reaction at A. We have hinge at B, so I have 2 reactions, YB and XB. This distributed load, what do you think? What should I do? If you divide it to rectangle, this rectangle has a centroid at the midpoint of 8. So we will have equivalent here. How much? 150 times 8. It will be 1,000 or 1,200 pound. And this distance will be 4, and this distance will be 4. That's clear. And we have another part. This part is right angle triangle. The centroid of this right angle triangle is located here. 1/3 from this side. 1/3 of 6 will be 2. And the 2/3 from the other side of 6 will be 4. This equivalent will be how much? Area of this triangle. 1/2 times 6 times 150. It will be 450 pound. This is your final shape. Then you can apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. So you can find your reactions. So you can do it at home. The last, this one, we are given also hinge at A, so we have 2 reactions, YA and XA. We are given roller at B, so we have reaction YB. How can I divide this distributed load? What do you think? You have many options. I do prefer to divide it to this rectangle. With a centroid at the midpoint, which is 3 meter and 3 meter. The equivalent of this rectangle will be 2 times 6 equal 12 kilonewton. Does that make sense? Then I have another part, which is this little right angle triangle. Hey, what is the value for this height? Is it 4? No, wrong. 4 is the total height. 4 is the total height. But this little height will be 2. And this distance is 3. So the centroid is located here at 1/3. From this side, 1/3 of 3 will be 1. 2/3 will be 2. And this is the equivalent force. How much? 1/2 times 3 times 2 will be 3 kilonewton. So if you would like to draw your beam to clarify everything, we have here one reaction YB. We have here two reaction XA and YA. And I have equivalent at the midpoint equal 12. And I will have equivalent here at 1 meter from this side equal 3 kilonewton. Then I can apply summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. Do you have any question? Do you have any question regarding the equivalent or the distributed load? Just to keep in your mind the two rules I gave to you. What is the value of the equivalent equal the area of this distributed load? If your distributed load is rectangle, what is the area of this rectangle? If your distributed load is right angle triangle, what is the area of this right angle triangle? If your distributed load is symmetric triangle, what is the area of this symmetric triangle? Where is the location of this equivalent? At the centroid of the shape, centroid of rectangle at midpoint, centroid of the right angle triangle at the 1/3 from this side and the 2/3 from the other side, the centroid of this symmetric triangle at the midpoint. Once you converted your distributed load to equivalent, we have right now concentrated. It's not real concentrated force, but it's equivalent. So I can work with this equivalent force and apply the equilibrium equations to figure out my reactions. Any question?